Hi friends, in this video we are going to learn how to write the dimensional formula of a physical quantity. At first, what is dimension equation? Equation is an equation which expresses a physical quantity in terms of its dimensions. How to write dimensional formula of a physical quantity? At first, let's consider the physical quantity that we have, the three physical quantities that we have. We have quantity here, quantity, and also what? Dimensions. Now, the first quantity is what? Is mass. And mass is measured in what? In kilogram. We have the second, which is our what? Our length. And it is in what? Meter. And we have the third one, which is our what? Time. And it is in what? Seconds. Now, what is the dimension of mass, length, and also time? The dimensional quantity of mass is taken to what? To be m. Then you simply write it out. The dimension of length is simply what? L. The dimension for time is simply what? T. So from these three physical quantities, all other quantities are being derived from what? From this. Now let's check how to write dimensional formula of a quantity. For example, let's consider volume. Let's consider volume. At first, what is volume? If you are talking about volume, volume is a space occupied by what? By a body. And volume is what? Is the combination of what? Of length by breadth and also by what? By height. Hope you are following me, guys. Then what is the dimension equation for volume? The dimension equation for volume should be what? Should be L. Since L is in what? Is in meter. Breadth is measured in what? In meter, right? Then height is measured in what? In meter. So you can simply call breadth and height as what? As length. You can simply make your breadth and also what? Height as what? As your length. Because they are all in what? In meter. Then this will be what? L times what? Times L. Times what? Times L. Then express it as what? Indices form. L times L times L will be what? Will be L raised power 3. Then our volume will be equal to, do we have mass here? No. Then you write mass is what? Is 0. Because if you consider the three physical quantities that we have, do we have one mass here? No. You write 0. Do we have length? Yeah. L is what? Is 3. That will be m L raised power what? Raised power 3. Do we have time? No. That will be t 0. Then the dimension for volume is what? Is m L T m L T. That's just it. So this is the dimension equation for volume. Then let's move to another one. Another one here. Let's consider speed. Speed is what? Is distance by time, right? Distance by what? By time. Then what's distance? Our distance is taken to be what? To be length, right? Distance of what? Of two objects is taken to be what? To be the length. Hope you are following me. The length through they are a bit different from each other, right? Then let's check it. Our speed is equal to what? Distance by what? By time. Then what's our distance? Our distance is taken to what? To be length, right? What's our time? We are having what? T. Hope you are following me, guys. Then speed will be equal to what? L over t, and which is what? Which is L t raised power what? Minus 1. Because if t come up, it's going to start what? It's going to start to minus 1. Then the dimension equation for speed will be, that should be what? That will be m, because we don't have what? Mass. You simply write m 0. What of L? We have L. L don't put 1 here. If you don't put anything here, it simply indicates that this L is what is 1, right? Then you simply write T minus 1. So this is the dimension equation for speed. Then let's check another one. Let's check for another one. I think we should check for velocity. What's velocity? Velocity is what? Is displacement by what? By time. Displacement by time. Then what's our displacement? Displacement is a vector quantity, and it is also taken to what? To be your distance. This will simply be what? Length. Because distance is also what? Length. That will be L divided by what? Divided by T. Then your velocity equal to what? Your L divided by T, right? And which, if this T comes up here, it's going to turn to what? It's going to turn to LT minus 1. Hope you are following me. And at first, do we have mass here? We don't have mass. That means mass is what? Is absent. You write 0, M0. Do we have length? Yeah, we have length, L1. Then do we have time? Yeah, that will be T raised power minus what? 1. So this is the dimension equation for what? For velocity. So now, let's check for what? For some other quantities. Like, let's check for density. And don't forget, density is what? Density is mass by what? Is mass by volume. Right? Then, if this is mass by volume, don't forget that this is another quantity here. You express this volume differently, and you express your what? Mass differently. Then density equal to what? Equal to our m, which is our mass, divided by volume. And what is the dimension equation for volume? Don't forget that volume is what? Simply L raised power what? Raised power 3. Right? Then you simply write it down here. We are having L raised power what? 3. Hope you are following me. Then your density will be what? Will be mass. We have mass here. Mass is not 0 here because it is what? 1. We are having mass here. That will be M1 L raised power what? Minus 3. Because if L comes here, it's going to start to what? To minus 3. Right? Then what of our time? Time is what? Is absent. That will be T0. Hope you are following me, guys. Then what other thing? Let's check for another quantity. Let's check for what? For work. Let's check for work. What is work? Work is what? Is force times what? Times distance. Force times distance. Then what is the dimensional equation for work? Force, express force differently. Don't forget that force equal to what? Equal to ME. That's mass times acceleration. Then under force, we're having F equal to what? Equal to M. What's our acceleration? Acceleration is what? Is velocity by what? By time. Right? And our velocity is another what? Is another quantity. Expressed as what? Expressed as LT raised power minus 1. Right? Sorry. Yeah, raised power minus 1, right? That's distance over time. This is just it. All divided by what? By our T. Our time. Which is time? We're having time here. So this simply means what? This is simply acceleration. Then our acceleration equal to what? Equal to LT raised power minus 1 over what? Over T. Right? Then let's put it inside what? Inside the force. So the dimension equation for force will be what? Will be M. Will be M L T raised power what? Raised power minus what? Minus 2. Because if this T comes up here, it's going to turn to what? To minus what? 2. Because you're having 2T here, it will simply be what? Minus 2. So this is the dimension equation for what? For force. Hope you are following me. Then let's come here. Our work is equal to what? Equal to force times distance. Then we simply add this as our force, right? That will be MLT raised power what? Minus 2 by what? Distance. What's our distance? Don't forget distance is taken to be what? To be length. Then this will be what? Will be L. Hope you are following me. Then this will simply what? W equal to what? Equal to M L times L. That will be L2 T minus what? 2. This is the dimension equation for what? For work. Can you see it now? According to our force, you will express it differently. Force equal to what? Mass times acceleration. Then our force equal to what? Mass multiplied what? By our acceleration. And acceleration is taken to what? To be velocity by what? By time. Then what's our velocity? Our velocity is what? Is distance over what? Over time. That's LT raised by 1. All divided by what? The time taken here. Then you put it here. After that, the overall calculation is what? Is F equal to what? MLT minus 2. Then you substitute this. If your F equal to MLT minus 2, then represent your F as what? As this. Hope you are following me. Then this will be what? Will simply be MLT minus 2 multiplied by what? By your L. Then L times L, we are having this 2L here. You express the 2L as what? As index form. Then you have your mass 1, L 2, T minus what? 2. Thanks for watching.